Good morning, everybody. It's Marty, the JavaScript party. Oh, my webcam is not on. Let me turn that off and on. There we go. And I got a nut for my buddy Rhett. There you go, girly. Don't drop it. Anyway, so she's making a mess on my floors. I think she's actually throwing the nut shells at our dog. Um, trying to. She's she's got she kind of has a mean streak in her. Um, But anyways, so we're working on unit tests and we're trying to get to 100%. I think every file except for one is at 100% now. Um, so now we're just trying to do that. I did see, like, I have a, like, since I've been doing unit tests on this project for a while now, I do have a very specific sort of set of schemes and stuff that I've come to achieve 100%. And then as part of that, it sort of breaks things down into individual line by line understandings. But anyways, here we go. And we see we have like, I always like to kind of go over this. So we have, holy cow, we actually have crossed 1,000 lines of code, that custom lines of code, 257 functions. So basically, our average line of code per function is about 4 lines of code. I have no idea if that's good, bad. I've literally never thought about that analysis, like what that even means. Um, I do like the idea that I have way more functions than branches. So I only have one uncovered branch right now. And then I have 7 more statements than lines. And I always forget what the difference between a line and a statement is, because I'm always so insanely um, disappointed whenever I figure out what it is. But let's go ahead and sort by statements. So this is it says it's a file, but it's actually two sets of files. And in there we have one uncovered branch out of 4. We have 8 uncovered statements out of 48. And we have 8 uncovered lines. So that means every line, everything we see that's uncovered is both a statement and a line. And we have 2 functions. If I remember from yesterday, one of our functions, so see, as you see, it kind of says like all files and kind of implies, oh gosh, it lost its state. It kind of implies that there's one file here, right? It says file, but this is actually a folder. And then in this folder, there's 2 files. And within that, we have this. And so apparently we never called the get animation from dictionary. And this thing can return an undefined or an animation. And there's absolutely no reason to do anything more than get an undefined back, because this just returns whatever it gets. So that is good. And this is in ST animation service. So what I'm going to do is I'm actually going to go to ST animation service. And I don't actually even need the whole thing. Service. And here we go. And now if you close this and then just reopen it, you're here. And then if you look in here, it's supposedly line 29 is the problem. And there it is. There's line 29. And so now I'm going to close everything else. Close others. And now we're going to go to our specification file, also known as spec. All right, so in here we want to just gets undefined from an empty dictionary. How about that? It. And, and I can't even tell you how many places I've worked at. Well, yeah, I can't tell you, but it's not like a whole bunch, probably less than 10, but I've worked at a lot of places where this is by far the best. Inside the unit test is the best documentation. So it returns undefined for an empty dictionary. That's what the test is supposed to do. That's the purpose of the test. And we give it a function. So it's going to run this function. And in this function, it expects to find a line of code called an expectation. And that expectation compares two things. And we know that it's going to say, we're going to say const. And what is this? An ST animation. Wow, so oh, okay. So this actually gets it for, I was like, shouldn't this just return an ID? This actually gets the animation for animation. And ST animation is going to be of type ST animation, or it could also be an undefined. And I've always wondered why, but I really like it. I like being able to say, hey, this could be undefined, because then TypeScript can catch issues for you. I have never ever added this or undefined to a function or to a PR that did not get rejected, where they said, "Oh yeah, no, don't do that." They'd rather you use like the exclamation mark on an input or on an input or something like that. They'd rather you even just lie and say that no, this is because like an exclamation mark on an input for a component is you saying, "Hey, don't worry your pretty little head. I'm going to end up. This is going to get yeah, I realize that this doesn't get set anywhere, but it's gonna get set. That's what the exclamation mark is. And most people that I've ever worked with that have been sort of elevated above me to, and then been told, okay, now you need to review this person's work, and it's me, I'm the person. Like most times they're like, they don't like that. They don't like you saying it could be undefined, and I don't understand that, but it's just kind of life. So service dot get animation from dictionary, and then we're just going to say one. We're just going to give it a number, and then we're going to say we expect the st animation to be undefined a thing to equal. I think that's what you can do to equal. Fortunately, we did have it to where it was able to help with this, and I don't know why it isn't now. And I definitely do not want to spend the time to figure it out because it's just annoying. Undefined. So we expect this to be undefined. So we're going to hit save, and then I'm just going to Alt Tab over to here and see that it actually ran. We should also be able to see it in our down here. It doesn't look like it picked up that new test. So let's go ahead and force a run. Yeah, so you could tell when it ran because there's all kinds of stuff in. I don't remember what we were at, but let's see if we have. Wow, there's four functions in. Yeah, I guess there were four functions throughout the whole application. Okay, so now that's covered. We have got 4 out of 7 functions now instead of 3 out of 4 functions. We have one branch that's uncovered, and we have 7 statements. So now we just scroll down, we'll find the next one. So this one gets an animations for a mesh ID, and this is a problem because we really need to pull this into its own function. Um, Now this one's hard because actually this one is very difficult to do that with because um, what happens is this is actually updating something outside of its context, right? So this has a context in here. It's trying to update it. So really, in my experience, the best thing to do in this is to pull this whole thing into its own function that returns the list of um, animations, right? And then we just assign that list of animations directly. So we have our ST animations, which gets Where does this thing get set? ST animations push. Oh, no. Oh, this guy. So this value gets set here, and it would probably be better if we just said, um, if this was just a function on its own. And once we break this into a function on its own, we're probably going to want to take this list and put that into its own function. So we got a little bit of work here to do, but it will make every function a little easier to understand. This is a bit of a, like, it's not that big of a lift to understand everything that's going on in here, but it is more of a lift than it would be to like understand this one. This is like a one-liner. It deletes it and it returns this delete animation ID. So I think it's going to return a true or false. I don't even know if this ends up returning what this ends up returning. So this one's like super easy to understand though. We know that it calls delete animation returns whatever it got. We know that. And we know that this always returns true. So that's a lot easier than than this to understand, even though this isn't that bad to understand. It's just like while you're working, you don't really want to have this extra set of cognitive load. And on top of that, you really don't want, um, like, it's very, 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 like, what do you call it? Like tempting. It's very tempting to like add more logic in here. So, you don't really, it'd be better to not. Um, so that's, that's really what I think. And then, but anyway, so let's go ahead and take care of these two today, and then I think I'll try to take care of this whole thing tomorrow. So we want to delete an animation for a mesh ID. And so it takes a number and returns true. So it runs these things. I think it should be fine. Even if it doesn't exist, it should be fine. So, um, so what are we saying? And this thing, like, basically, um, deletes an animation given the ID. So that's all we're saying that it does. We're not saying that it actually deleted it or anything like that. We're just saying that, hey, this thing runs. Its purpose is to do that. I guess we're not testing that though. I guess we're just testing that it executes deleting an animation. Now, I guess I was kind of being a little sneaky there because I'm trying to. I really primarily care about two things. I care that we have 100% coverage, and I care that we are um, that we have 100% coverage, and that every line of code makes some sense on a line by line basis. That it makes sense that it's readable and has some sort of it's reasonable. You can reason about it. Um, so const result delete result is equal to. So right now what we're doing, and this may actually break in the future, and if it does, I actually do want to think through it. But this could very well break because I can imagine a scenario in the future where we start returning if it doesn't exist, we return a false. Right now we always return true. We just blindly attempt to delete it and then we return true. That may not be and that's perfect for right now, but it may not be in the future. Service dot delete animation for a mesh ID. The delete an animation, and this actually accepts an animation ID and a mesh ID given a mesh and animation ID. And like it's so tempting to start like diving into like, okay, why are we deleting, doing all that? But it's like I don't really think that's the job at at unit test time. I think at unit test time, the whole idea is just to understand what the function is supposed to do and what each line of code does, not how it fits into the overall all picture. And you can really get a kind of a distorted, messed up view of things if you try to go down that path. Like this is a path that's very, very good for microscopic level perfection. That's what this is for. And the second you start trying to misuse this for understanding the overall architecture of the application and making sure that the spirit of whatever is trying to be done is being done, you are destined for misery. But anyway, so let's see what happens. I'm just putting two random numbers in, and I guess we should add a note. Neither ID exists, and then it's probably better to say const mesh ID st mesh ID is equal to 1 and const st animation ID is equal to 2, and then pass it in a mesh ID and an animation ID. And like to me, this seems so incredibly obvious and like rational. But in the future me is probably not going to think if I just lay eyes on this and I haven't thought through things, I'm probably going to be like, why would I do that? That doesn't make a bit of sense. Okay, so mesh ID does not exist um, in this unit test. And it may actually, because it wouldn't surprise me in the future if we um, go up here and like before each start adding things. That wouldn't surprise me. So this may not stay true. And if it doesn't stay true, it'll be very clear to me that okay, I'm bonkers at that point. Animation ID does not exist in this unit test. And now I'm going to hit save and hope that this is no longer red and that we have a better statements and branches. I think we'll just get one statement. And then, and then, oh Lord, I hear him out there talking about taking the player I want. So I'm in a fantasy football league, and I have the ninth pick overall, and my wife has the fifth pick overall. And there's a player I want that I feel like is really well suited for me, but not quite very well suited for other people because he's going to probably be a backup. But I have the primary too, so if my primary person who I really count on goes down, he's very likely to be the backup. But I think that my primary guy might be down for one game or something, but we'll see. So like, but I don't know. But the thing is, in my league, quarterbacks are just so much more valuable than everything else that it's tough. It's a tough one. I would kind of be glad. It's nice to not have choices though. Okay, so actually both of these ended up getting called, which makes sense to me. So we probably actually picked up four statements. And then let's see, 92%. So we only have three lines of code and one branch. Now it's not this is going to be by far the most difficult one because what I need to do is pull this whole set into its own function and return return the list of animations. So then this up here, oh, actually this is trickier because const st oh no. I was thinking that there was more than one mesh. So my animations, no, it goes over. Oh, okay. Yeah, it goes over each mesh. Oh, no. Okay, so it's not looping. Okay. I thought it was like looping over meshes, but we only have one mesh, right? That makes sense. And then, yeah. So, anyways, that'll be fun. I think this turns into two new functions, and then I'm hoping to not even have a branch here. I'm hoping that this is just like it returns a true or false, and then we just return that, and we don't have to worry about that. So, anyways, that's going to be a little bit tricky and interesting to me. Happy coding, everybody. Have a wonderful day. Saturday, the 2nd of May. Oh, yeah, yeah, 2nd of May. How everybody have fun. Bye.